What is the geometrical term associated with the line joining any 2 points on the giant wheel which represents a circle?
At the end of this lesson, you should be able to describe circle and its basic terms, identify the various parts of a circle, prove equal chords of a circle, subtend equal angles at the center. Prove its converse. If the angles subtended by the two chords of a circle at the center, corresponding centers, are equal, the chords are equal. Prove that the perpendicular drawn from the center of a circle to a chord bisects the chord. Prove its converse. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Look, John is playing. He throws a stone in the calm waters and watches the ripples formed in it.
What shape does it resemble? It resembles a circle.
Yes, the ripples are circular in shape. John looks at the setting sun and thinks, the sun appears like an orange ball of fire engulfed by the sea. It's time to go home. He picks up his bicycle and drives away. What is the path traced by the rotating edge of the rims of the bicycle? The path traced by the rotating edge is a circle. A circle is the collection of all points in a plane which are equidistant from a fixed point. To draw a circle, take a compass with a pencil fixed at one of its ends. Place the pointed leg to a point on a sheet of paper and rotate the other leg through one revolution.
Let us now identify the circle and the terms related to it.
Here, the fixed point from which the circle is drawn is called the center. The fixed distance between the center and a point on the circle is called the radius of the circle. The region inside the circle is called the interior, and the region outside it is called the exterior region of the circle. So, the circle and its interior make up the circular region. Identify terms related to circles to solve the crossword puzzle. If the student keys in the correct words, the green light is shown. If the student keys in a wrong answer, a red light is displayed. We have all seen a guitar. Can you find what part of the circle do the strings of a guitar represent? The strings of a guitar represent a chord. We know a line segment that passes through any 2 points on a circle is called a chord. How many chords can a circle have? Is diameter also a chord? A circle can have infinite number of chords. Diameter is also a chord of a circle, which is twice as long as its radius. It is the longest chord of a circle. Now, take a look at the pieces of the circle between the points A and B. A piece of circle between 2 points is called an arc. The longer one is called the major arc and the shorter one is called the minor arc. Here, the longer arc of AB is denoted by ACB and is called the major arc, and the shorter arc of AB is called the minor arc. If both the arcs are equal, then what will be the region formed by each of the arcs? The region formed by each arc is a semicircle if both the arcs are equal. What is the region between the chord and either of its arcs? The region between the chords and either of its arcs is a segment. The segment corresponding to the major arc is major segment, and that corresponding to a minor arc is called the minor segment. Here, ACB is the major segment and ADB is the minor segment. What is the region between an arc and the 2 radii joining the center to the end points of an arc called? The region between an arc and the 2 radii joining the center to the end points of an arc is called a sector. Sector corresponding to minor arc is minor sector, and that corresponding to major arc is called major sector. Here, the external angle of AOB is called the major sector and the internal angle of AOB is called the minor sector. Look, John is clicking the photographs of a building from different angles. Here, the length of the building represents a chord of a circle of center O. Can you name the different angles subtended by the chord PQ of the circle? When John took the photograph from the center of the circle O, the angle POQ is the angle subtended by chord PQ at the center of the circle. When John photographed the building from points R, S, and T, they are the angles subtended by chord PQ in the major arc PQ. Similarly, when John photographed the building from point U on the circle, then angle PUQ is the angle subtended by chord PQ in the minor arc PQ. Here is a table of figures of circles with different chords and angles subtended by them. What relationship do you observe between the chord and the angle subtended by them? From the table, we observe that the chord BC subtends angles 55.52 degrees and 24.98 degrees depending on the length of the chord. So, we can conclude that angles subtended by the chord in the same segment are equal. A longer chord subtends a greater angle compared to the shorter one. You must have observed the steering wheel of a car. Can you find the relation between the angles formed at its center? If the distance between the segments of a T-shape of the handle forms two equal chords, then it subtends equal angles at the center. What do you conclude from this? Equal chords of a circle subtend equal angles at the center.
Let us now prove that equal chords of a circle subtend equal angles at the center. Given AB and CD are equal chords of the circle with center O, prove that angle AOB is equal to angle COD.
In triangle AOB and COD, OA is equal to OC, radius of circle, OB is equal to OD, radius of circle, and AB is equal to CD.
Given
if three sides of one triangle are correspondingly equal to three sides of the other, then the two triangles are congruent. This is SSS congruency criterion. Therefore, triangle AOB is congruent to triangle COD. So, angle AOB is equal to angle COD as they form corresponding parts of congruent triangles. Suppose I cut the disc along AB and CD and superimpose them, then what conclusion can I draw from this? The two chords cover each other, that is, they are congruent. So, AB is equal to CD, the length of the chords are equal. Can you prove this using logical arguments? In triangle AOB and COD, OA is equal to OC, radius of circle. OB is equal to OD, radius of circle. Angle AOB is equal to angle COD.
Given.
So triangle AOB is congruent to triangle COD, SAS congruency criterion. So, we can conclude that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Now, let us do a small activity on chord to understand some of their properties. Let AB be a chord of a circle with center O. Fold the paper along the line through O. The crease cuts AB at the point M. So, angle OMA is equal to angle OMB and OM is perpendicular to AB. What do you conclude from this activity? From this activity, we conclude that point B coincides with A and the length of the segment of chord MA is equal to MB. Then the line drawn perpendicular from the center of a circle to the chord bisects the chord. Suppose M is the midpoint, then
let us prove that the line drawn through the center of the circle to bisect a chord is perpendicular to the chord. Let AB be the chord of the circle with center O, and O is joined to the midpoint M of AB. Prove that OM is perpendicular to AB.
This can be proved by considering the two triangles OAM and OBM. Here, OA is equal to OB, radius of circle, AM is equal to BM, and OM is equal to OM, which is common. So, the two triangles are congruent by SSS congruency criterion. Therefore, triangle OAM is congruent to triangle OBM, and angle OMA is equal to angle OMB, that is equal to 90 degrees. So, OM is perpendicular to AB. This proves that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord.